Okay, so I'm going to go through drawings and basic circuits here. The first mod in controls and switching circuits. This one's kind of a general one and gets us into the stuff that we've talked about before in second, potentially in third year as well too, just about control of a motor and some different ways we can do that and the different types of drawings and symbols. So we'll go through this and then I'll tell you also what you got to do for your first lap. So it starts out just basically going through some of the common symbols and then their names and their descriptions of what we would see. So we're going to see this is our motor magnetic. That's going to be our coil inside of our starter. So again, when we started talking about a schematic diagram where we're turning a motor on, it's not the motor we're turning on directly. We're energizing the coil inside of the motor starter, and that's what's closing the contacts for the motor to start. So we have our normally open, normally closed, all these kind of symbols. So just go through these, have an idea, difference between normally open, normally closed. When we put these symbols into a schematic, they are in there as in the de-energized state or empty is what they refer to it as. So the energizing of the coil or whatever they're associated with changes the state, but in the schematic they are in the de-energized state. This is the difference between proximity switches, limit switches, temperature switches, that kind of thing, set overload heaters. Then we get into timing symbols as well too. We'll talk about these when we get into special circuits. So the TDOE, TDOD, that kind of stuff. Then we have IEC as well. So all these ones we've kind of shown here are more NEMA style. These are the IEC style. So same thing, normally open, normally closed, contacts, overloads, they just look different. And again, you could see either one of these, NEMA or IEC, in your field experience. So definitely have a difference, know the difference between the two. Okay, so normally I go through and it's a class and we name these things, but definitely go through the mod. This, again, we don't call this a start. This is a normally open momentary push button. That's what this one would be called. Normally closed momentary push button. So not a stop necessarily. They want to know exactly what the name is. Okay, and then you can see when we have a relay, if we have a set of contacts that's operated by that relay, they have the same numbering. So R1, so when this becomes energized, this guy closes. Here's an R2, so when this guy's energized, this one opens, and so does this one over here, this normally closed set of contacts. Okay, so they're labeled with the same number and letter that a coil is marked with, so that we understand as electricians looking at these drawings which one is which contacts are associated with which coil. Here's again, this is for another question in your module, but this is an IEC. Again, IEC, we are labeling our coil A1, A2, different look of the coil as well too. It looks kind of like a sideways version of a what we would be used to seeing of our normal schematic, normal being just the most common. For a NEMA, it looks like it's been twisted 90 degrees. So here's the rung here, and here's a rung here. And then, or the side of the ladder, I guess, and here would be the rung here. So here's the holding circuit, again in parallel with what would be a start, but which is a normally open momentary push button again, and here's a set of hold contacts, or the set of normally open contacts associated with this coil, and they're labeled 13 and 14. Okay, so definitely have an understanding of the difference between the NEMA and the IEC, because we'll get through, we'll go through and ask a lot of questions about that. So then they start talking about different types of diagrams. We start off with a block diagram. Block diagrams, they're again usually just to show the relationship between equipment or systems. It's an overview rather than a specific construction and wiring detail. They may show the difference between a floor, like, so here's a second floor, main floor, basement, but you're not seeing any connection points at all. It's a very general diagram to show you kind of what's going on. Then we talk about a wiring diagram. So the difference between a wire diagram, it does show some of the detailed wiring for the control devices and equipment. Some individual conductors are shown connecting to specific termination points. So here we're actually seeing a wire connected to this terminal and this terminal. So this is going to actually tell us how to wire this stuff up. Maybe not show us how things are working, but we know that in this example we go from this point at 13 and go to the stop button. Okay, so that's a wiring diagram. Now when we talk about a schematic diagram, and they say also known as an elementary wiring diagram, and that's going to show basically more of a sequence of operation. We're going to still see a connection point, but we're going to see the functionality more of the circuit. So we know if this gets pressed, it affects everything over here. And when this becomes energized, it closes these, which affects the circuit. So we can see a lot more what's going on in the schematic, and that's the one we use quite a bit to show us the actual functionality and make sure that the circuit is going to operate as intended. So this is a NEMA style. So we see our terminal here, 1 coming off line 1. Our holding circuit is right here in parallel with the start, which is associated with this motor magnetic. So this normally open set of contacts is what we use as the holding circuit. So they're associated to this coil, so when this coil becomes energized, these close, and we can see that by the M label here. So this M contact is associated with this coil becoming energized. Then we have our overloads. Again, every motor circuit needs overloads. In case it gets into that scenario, it opens this and shuts down the circuit. In NEMA, specifically, we have this labeling of 1. The holding contacts, or the normally open contacts associated with the coil, are labeled 2 and 3. And our overloads are at the end of the circuit hooked to line 2. And they're just labeled as overloads. Here would be a NEMA style schematic. Okay, so not the vertical or the 90-degree twist on the rung. This is a NEMA style schematic, with control circuit for an IEC style motor starter. So we've drawn it in the NEMA style, but we're labeling it with IEC. So as soon as we do that, the difference between this would be NEMA style and labeling. This is NEMA style and IEC labeling. So when we look at the big things, the coil actually has a label now, and they're called A1 and A2. Our normally open contact associated with the coil, so still labeled M here to show us that it's associated with this coil, but they're labeled 13 and 14. And then our overloads are at the front of the circuit, so they're attached to the line 1 instead of the line 2. As soon as I see that, it tells me instantly that this is IEC labeling. The other difference is the overloads are actually labeled with numbers 95 and 96. And these numbers are literally, they're right on the motor starter itself. So we can see all these, and we'll see them when we do the lap. Other than that, functionality of this circuit and this circuit is exactly the same. Just the labeling is different. Now here's an IEC style schematic and labeling. So this is NEMA style, NEMA labeling. NEMA style IEC labeling. This is IEC style and IEC labeling. So this is where we kind of flip things on their side a little bit. We start this way, line 1. So here's our normally closed, our overloads, 95, 96. Then we have a stop button, or a normally closed momentary push button. Then we have a normally open momentary push button, which is acting as our start. And then here's our hold circuit, the 13 and 14. And here's a set of normally open contacts called KM, because they're associated with this coil. So when this KM coil gets energized, this changes state. And there's the KM is not necessarily a default or something you're going to see all the time. The A1 and A2 is definitely what we're going to see all the time. Okay, and then that's our coil going to line 2. So same labeling as this scenario, just in the IEC style. So different style buttons and I guess rung location by spinning it there on us. Okay, so that's the big thing with the difference between IEC and NEMA. So then this figure says figure 8 is a more complex motor control circuit for a compressor driven by 2 motors. Alternate motors will drive the compressor each time it operates, and both motors will run if required. Notice the numbers on the side of the schematic. Okay, so that's these numbers right here. These numbers here. Okay, those along the left-hand side of the drawing are the rung number. So that's here, these left-hand sides. So that's the number of the rung of the ladder style schematic. Numbers on the right-hand side indicate the rung number location of the contacts of a relay or contactor coil located in the rung to the left of the numbers. For example, relay CR1 in rung 4 has contacts located in 4 and 9. So here we see right here, here's CR1, and it's got contacts in 4 and 9. Here's a contact here in 4, and if we go down to 9, there it is right there. So these numbers here are going to tell us where the contacts are associated with these relays or coils. So here's an M2. I would look for the M2 contacts in rung 5 and 10. So I go to 5, there's an M2 right there, and 10, there's an M2 there. So it's just a way for us to help us find exactly where all the contacts are that are associated with these coils when they become energized. Whether they're relay coils, so that's a control relay 1, control relay 2, or whether it's a motor magnetic for a motor starter. Okay, because we can have multiple contacts off these guys in different areas of the circuit, and these will help us find them quickly. Last one they talk is the interconnection diagram. They show specific connection details, so no attempt is made to provide an indication of the function or location of components. It's literally, red goes to 8, or black goes to terminal 2. You could literally have no idea what these are doing, but still be able to connect this correctly. That's what an interconnection diagram is going to do. This is a pinout, same kind of deal, where we just know, hey, the yellow wire goes here, white goes here. You, again, don't need to have any understanding of the circuit or what's happening. As long as you have a pinout, you could literally sit at your desk and make 600 of these, and they would be correct. This would be like for a military connector or an Amphenol connector, that kind of deal. Okay, so you could have somebody sitting and making these up and not know anything about the circuit at all, and we can use an interconnection to do that and still be 100% correct in what we're doing. Okay, then objective 3 gets us into some basic motor control. Motors, again, must be provided with the means to start and stop them with overload protection. Motors may also be required to react to other parameters such as heat, pressure, motion limits, fluid levels in tanks, all that kind of stuff. So we have to design our motor so that it can be started and stopped. Again, we talk about the two different times, whether it's low voltage protection or low voltage release. Once we get into the start-stop scenario with a hold circuit, with these momentary buttons, we're definitely into a low voltage protection scenario, so that when the circuit comes back on, we would have to physically press start here. So we have different sections of the circuit. We have our stop circuit, our start circuit, and our holding circuit. That's the 3 sections we're going to talk about. We're going to talk about these specifically because we're going to add a set of contacts into all these different sections and see how it affects the circuit. And we talked about this in second year as well too. So we'll just review the NEMA and IEC portions of it, and then we'll see what happens when we add those contacts. So again, this is the NEMA style. We see the 2 and 3 on the hold circuit. The overload's on the right-hand side of the coil here, hooked to line 2 with no numbering. Then we look at, again, this would be a NEMA style with IEC lettering and numbering. So still our stop circuit here, but now we see the overloads. Again, I would have an expectation of seeing the 95, 96 there, or sorry, what was that? Yeah, 95, 96 there. They don't have that. I would think they would. This one, we got our coil A1 and A2, and our hold is 13 and 14 instead of 2 and 3. And then we have, again, our IEC style and labeling, and we have, here's our stop section, again, with the overloads in the stop section, because it's IEC. We have our start and our hold, and that's kind of the same as the other ones we talked about. So let's talk about adding these contacts. So basically this scenario here, we have a regular start stop, and we've added a set of control relay contacts. That control relay is energized when this heat switch, so it could be a thermostat or whatever it is that's activating this relay. So we kind of look at these scenarios. So now we have this contact in the stop circuit, so it's in this section right here. And when we have it in the stop circuit, what is it going to affect? Is it going to affect the starting or the stopping of this circuit? Well, we kind of have to look at these contacts in both states. So if we look at it in the open state, is it affecting the starting? Well, yeah, if these are open, I cannot start the circuit. So when they're in the stop circuit, so in this location, Do these contacts affect the starting of this motor? Yes, 100% they do. Now, if they're closed and I'm running and this is closed and this control relay is energized, if this opens and de-energizes this control relay, then this opens. So if we're running, and when we're running, we press start, then we're running through the hold circuit after we've let go of the start button. Well, if this motor's running through the hold circuit, so this would be closed, and this would be closed, and it's running, everything's fine, then this becomes de-energized. This set of contacts here, this control relay contact, is going to open. So then it will stop the motor. So the long and short of that is this set of contacts in the stop circuit affects the starting and the stopping of the circuit. Okay. Now we talk about, well, we moved it into the start section. Okay, so we're not in the stop anymore, we're in the start. Here's the hold portion and here's the start. So we look at it again with these contacts open and closed. If they're open, can I start this motor? And the answer is no, because I have a brake here, so if I press start, nothing's going to happen. So it definitely affects the starting. Now, if this is closed, the CR contact is closed, I press start, it's going to energize this coil, which is going to close this, and my motor is going to run through the holding circuit. So that would be if this was closed. So then I can start it and everything's fine. Now, if I'm running through the hold circuit and this becomes de-energized, these will open. So does that affect the stopping? And the answer is no, because I'm going through the hold circuit. So if these open while the motor's running, it's going to have no effect on the motor at all. So if I have a set of contacts in the start circuit, it's only going to affect the starting. Okay, so only the starting if it's in the start circuit. Then the last scenario, we put it in the hold circuit. So now we say, if this is open, can I start this motor? Can I press this button here and start this by engaging this, by energizing this, sorry, and starting the motor? Yeah, I can start it all day. If I let go, it's going to stop, because if this is open, it's going to basically, it gets rid of my hold circuit. So it kind of turns this button into a jog. But every time I press it, that motor will start. So it does not affect the starting. I can still start that motor. But if this control relay is closed, I press start and I'm running through the hold circuit now, because when this is energized, this closes. If this is closed as well, then I'm running through the hold circuit at that point. Now, if I'm running and this control relay opens this set of contacts, then I will stop it. So it does affect the stopping, not the starting. So to review, in the stop circuit, it affects both the starting and stopping. In the start, it only affects the starting. And in the hold, it only affects the stopping. Okay, so that's kind of the three scenarios they talk about in your mod for putting these set of control relay contacts in the different parts of the circuit, so we have an understanding of what's going on. Then it talks about multiple control points, so starting and stopping from more than one location. Basically what we're going to do is put stops in series and starts in parallel. Okay, so again, in series, because if either one of these is pressed, it's going to stop the circuit. And again, these aren't physically located beside each other. Potentially there are two stop-start stations, could be on different areas of the room. So you'd have a stop-start station in one area and a stop-start station in another. If either one of those stops is pressed, we need to be able to shut down this motor. So they have to be wired in series, even if they're not physically close to each other. And the starts have to be wired in parallel, so that if I press either one of those starts, it's going to start it. If we had the stops in parallel, we would have to press them both at the same time in order to break the circuit. Okay, so we have to have these guys in series. And same thing, if we had these in series, we'd have to press both starts to start it. So that would kind of lose its effect. So that's why we put the stops in series and the starts in parallel, to have multiple control from multiple locations. And then they show it again in the IEC. So here's a stop here, here's another stop here, again showing them in series, and then showing our two starts in parallel. Again, very similar between the two, we've just got a difference in numbering. Make sure and go ahead and give this a try. I won't go through and label this one and do it right now because that's kind of what the next mod's is all about, is going from wiring diagrams to schematics and that. So give this a try. It gives you the answer in the module, but in my next video I'll definitely show us how to do this. What I do basically is I label each wire with a letter, and then I transfer the lettering down here, and then I draw it out, and it will tell you how many wires you need in each one of these. Just remember there's a junction here, so you can make splices here. Okay, so I'll go through this, but I kind of want you guys to have a try on this first before we go through it. So give that a try and the rest of the exercises, and we'll go from there. I'll make a video for diagram conversions next.